Is about writing and representing algebraic expressions. Okay, so on your test you're going to see a table filled in with 3 columns that has steps, the algebra tile picture, and the algebraic expression. So this is just like the math magic trick that we spent a couple days practicing, and we have to fill in the missing pieces of the steps. So we're going to think back to when we started, and we said pick a number, and we needed an algebra tile that would represent that picking number. Well, since everybody could pick a different number, we needed a variable. We needed a changing tile. So one that didn't represent a specific one, which happens to be our X tile. That way, when we say pick a number, no matter what number that person picks, it can be represented by X. And when we're talking about our algebraic expression, we are looking to see what, making sure it's a different color, we're looking to see what tiles we have and how can we write the name of those tiles. So in this step, our pick a number step, the only tile we have is X, so our algebraic expression is X. We remember from 7.3.4 that algebraic expressions mean there's no equal sign. All right, then the next one doesn't give us our steps, so we actually have to find that out as well as our algebraic expression. And we can look right now at the algebra tile picture that we have, and I can see that I have one X tile still, so I'm going to write that as X. And then we have 1, 2, 3, 4 ones, and we are adding those, or we're combining those. So we have X plus 4. So then we're looking, how did we get from this algebra tile picture to this one? How did we get from X to X plus 4? Our step then is add 4. Now we have the step for our next one, and it says to triple the result. We need to triple the result. If we're tripling the result, we're really multiplying by 3. So we're going to take this whole set and we're going to multiply it. Oh, it's not going to let me. Okay, well, maybe it will. Nope. We're going to do 3 of these exact same lines. So we're going to have 3 groups of X plus 4. So there's one group, doing the exact same thing below it. That's group number 2, and then my third and final group there we go. Okay, so now I have 3 groups, and I can highlight them for you so that you can see them really easily. There's one group. There's a second group. And there's my third group. So there's 2 different ways that we can write this. Now we said we were going to triple, which means multiply by 3, and we were going to triple what we had before, which was X plus 4. So really what we have is 3 groups, which is that 3 on the outside, of X plus 4. We could also think about this as, again, just counting the tiles that we have. So I can look and I can say I have 1, 2, 3 X tiles, so that'd be 3X, and I have 4, 4, and 4, and I know 3 4s is 12, so 3X plus 12. Now, if you remember the distributive property, I'm going to go back to my pen. If you remember the distributive property, we said that we can do 3 times X, and we get 3X, and 3 times 4, and we get 12. So there is the 2 different ways that you could write that. All right, then we have just the algebraic expression, So we have to figure out how we went from 3x plus 12 to 3x plus 6. What did we do? Well, the x's stayed the same, so I can just take my 3x's and put them there. And then I still have 6 tiles. And notice how I'm distributing them evenly among my x's. I'm just keeping them nice and consistent. So there's 4, 5, and 6. So what happened? Well, I subtracted 6. My next step would be subtract 6, because I went from 12 to 6, but my x's stayed the same. Okay, so now looking from this picture to this one, what did we do? We have to figure out how we went from 3x plus 6 to just x plus 2. And I'm thinking about even groups. How can I divide? Because really, I can't say that I subtracted anything because I have to do the same thing to each set of tiles. So I would have to go from 3x's to 1x, I would subtract 2x, but that wouldn't affect my 1's at all. So I have to divide in this case. And if I had 3x's before and now I have 1, let's check and see if dividing by 3 works. If I do 3 divided by 3, I'd get 1x, which matches my picture so far. And then to go from 6, since I divided by 3 with the x's, if I divide by 3 with my 1's, 6 divided by 3 is 2, and I see 2 here. So that makes sense. So this step had to be divide by 3. Okay. Now, our last step tells us what the step is, which is subtract our original number. When we go back to the top, we had pick a number, and that number was x. So we're taking away our original number. So if we take away x from our x plus 2, all we are left with is 2. So our algebraic expression for this one is just 2. So there you have it. We have 3 different representations for our math magic tricks. You can take a look at some more examples from the book. If you look in CC1, Unit 7, that would be 721 to 723. All right, thanks guys.